Hello everybody, in this video we're going to look at topic 5, lesson 1, example 4. We're going to simplify an nth root and we're going to try it on your own. I guess we're not going to try it, you're going to try it on your own. That's what's going to happen. So we're going to do simplification of 32m to the 15th power. And the way I like to do this is I like to break these things apart. So I'm going to look at the 32 first. All right, I'm going to look for anything that would give me a fifth exponent or multiplying 5 times. So I'm going to break this down as far as I can to its prime numbers. So 32 is, I believe it's 16. No, 4 and 8. Let's do 4 and 8. All right, so this is going to be 2 and 2. And this is, so now we're at primes here at 2 and 2. This is going to be 2 and 4. So we have 3 primes here, and we still have a non-prime right here. So I'm going to break that down to its primes, which are 2 and 2. All right, now we are in our primes. And looking at this, I'm multiplying 2, 1, 2, 3, 4, 5 times. So 32 can be written as 2 to the 5th. All right, so let's redo this. Let's rewrite 5. Actually, I'm going to rewrite this as 2 to the 5th times m to the 15th raised to the 1/5 power. Okay, looking at an exponential property here, if I have a times b to the c power, I could say this is ac times bc. So I could raise each of those factors to the c power. So in this case, this is going to be 2 to the 5th to the 1/5 power times m to the 15th to the 1/5 power. All right, next exponential property is ab raised to the c power would equal ab times c. So 5 times 1/5 is just going to be 1. 15 times 1/5, well, that's 15 over 5, which is going to be 3. So my simplification here is 2m cubed. Right? So why do even roots sometimes require absolute value symbols while odd roots do not? Because an even root, you can have a positive or negative contributing to that even root. So if I have -2 squared, -2 squared would still be a 4. So if I take the absolute value of -2, I still get that 2 squared will give me the 4. And that's just why even roots sometimes require the absolute value symbol. To simplify the expression, assume all variables are positive. Right, so what they're saying here is because these are even, we're not going to look at the positives and negatives. We're just going to look at the positive aspects of this. We're only looking at the absolute values of this. Right, so there's no base number here for me to break down like the last one we had, 32. We don't have a base number here. We only have exponentials. So in this case, and just so you know, x and y, this guy right here would be my base. Well, this would be my exponent. All right, so looking at this, I'm going to rewrite this as x20 times y to the 8th raised to the 4th power. Using the exponential property, a times b raised to c would give us a to the c power times b to the c power. I'm going to move 4 across each of these. I'm going to raise each to the 4th power, so x, it's not the 4th, it's the 1/4, x20 to the 1/4. Sorry, is in this explanation of base that I didn't finish writing my thought down. 8 to the 1/4. Okay, again, we multiply a b to the c would equal a b times c. So 20 times 1/4, that's 20 divided by 4, which is 5, times y8 divided by 4, which is going to be 2. And so because this is x to the 5th and we're only looking at positive values, I'm going to put that in the parentheses, because anything to a odd number can be a positive or negative. But if I have a negative in a square root, then we're looking at the imaginary, and we don't want the negative in the square root, or sorry, in the radical. I'm saying square root, I mean radical. I'm doing the common misconceptions from before. But since we're putting it in the radical, we don't want a negative in the radical when you have an even index number. So when you have an even index number, you have to have absolute values in here. If not, then you're going to be looking at that imaginary, the complex number. All right, so there you go. Here is your triads. Those are not nice numbers. This is a 3 index, which means you can have a negative in here. This is a 4 index, which means you cannot have the negative in there. So make sure you pay attention to those indices. And I will catch you in the next video.